Hi, welcome back. Okay, so now we're looking at the next three scenes are going to be the level scene, the mode scene, and the player scene. These aesthetics are used in the configuration part of the components that we talked about. Um, and as you can see, the scene is pretty much simple. There is no background; it's just a black color. And there's three labels, description labels, and three buttons, and it's got typical lighting and main camera and so forth. You need that. There's the ship profile, which is a background picture. It's a picture of some kind, a bitmap. But pretty much everything is very simple on these screens. And you'll notice that there's the skill level controller. That's a game object that belongs to the scene, and that's where audio is put in for the clicking sound for pressing the buttons, and the actual main controller script for the that scene, which is the level controller script. All right, so you have your buttons, the standard buttons, just like we showed before. There's a caption, as you can see off to the right. There's a panel, as you can see off to the right. And that's it. That pretty much covers the buttons. So these buttons are no different than any of the other buttons, how they're made. And that is the level scene. Now let's move on to the mode scene. And the mode scene, like I said, is no different than all the other scenes. The only thing that's really different is the image that's used on the side to distinguish between the scenes. Because if I didn't put an image there, then it's very easy for the user of this interface to get confused, and they won't know where they are. So they could think they're setting the level from easy to hard, and then they find out they really changed it from Goombot to human, and they're wondering why Goombot isn't making any moves. So each one of these has a very obvious image picture that's put on the scene, so that you can distinguish between scenes when you move between scenes, because the buttons are the same number of buttons, same style of buttons, and what's different is the text. All right. And now we'll move on to the player scene. As you can see, it's the same concept. And what makes these different, what makes the three scenes different, level, mode, and player, is actually the scripts that are played. They do different things. But as far as visually, they're pretty much the same. And again, that's why there's the image there distinguished from one scene to another, so that the player doesn't get confused. All right. And that takes care of the configuration portion of the aesthetics. So let's move on to the actual scripting and the coding and the game mechanics, and we'll see how the magic is performed. All right, so right now what you're looking at is the scripting editor of the Unity 3D development system. And you'll notice off on the left, there's a series of scripts. They're classes, they're C# classes. And I've opened up a few of them along the top. You'll see the tabs. And we'll go in and look at them. The structure behind these scripts and classes are, there's some reasoning to my madness, and or madness to my reasoning, whichever way you want to look at it. You'll notice that there are two classes associated with every scene. All right, there's, in the case of the home scene, you see that there's a C home scene controller, and there's a C menu button class. So I could have called it C home buttons to be consistent, but it just seemed to make more sense to say they're menu buttons because that's really what they are. So, you know, if a person looking at this wants to get to the menu buttons, they'll see menu buttons and go there. But if they see home buttons, they may or may not know that. But everywhere else you'll see there's C level buttons, C level controller. C mode buttons, C mode controller. C player buttons, C player controller. Okay? And that's because they're designed to work together. One script handles the events that come from the buttons, and the other script is the actual main program, if you would, for that particular scene. Now, in Unity 3D, when you load a scene, all the data that's available from all the other scenes is gone. It gets released, the memory's released, so you don't have it. So what I try to do is that I try to take advantage of the player preferences property control, and it's designed to retain some persistence of information across scenes. And if I use the save command, I can save this data to a file, and then that file will be opened up at the beginning of the game, and the information is brought in, and that's used for saving last level played. Do you want to continue at this level if you stopped in the middle of it? Do you want to start a new one? Scores that the highest score you've done so far, and things like that. That's where you store that information. So we're going to look at the C home controllers first, because that's the when you first start the game, that's the scene that comes up first. It's the home scene, and this is the home scene controller. So as you can see, the first thing you should notice is that the class C home controller derives from C common constants. C common constants are all the numerations and constants that I use that are part of the configuration. And that information has to be available to all the classes, all the scenes. So if we go to the common constants, you'll see that this class, as it says, it's all enumerated types, because I've enumerated the data. Okay, that way, if I just did it with regular constants, you may not, if I put the wrong value in, it may be the same number, maybe, like easy, look at, like say in the case of easy hard and easy hard done button, okay? There's a difference between skill level and the buttons. So, but they're both 0, 1, 0, 1. So if I had just used constants, it wouldn't be clear which one of these that I was using. But if I treat them as enumerated types, now the compiler will make sure that I'm using the right one because I've defined it as a type. All right, and it'll flag it so that there's some consistency. So I don't get these erroneous errors that'll happen at integration time because cut and paste issues and so forth. All right, you'll also notice that it's serializable, and you have to do that or else Unity 3 can't see it when it's attached to all the other classes. So you have to make it serializable. It's a form of exporting into external mode so that everything else can see it. Now, you know that all classes must derive from mono behavior. So here in this case, the C common constants derives from mono behavior, and all the classes that care about the parameter information, configuration information, derive from common constants, and they'll also derive, because that derives from mono behavior, they'll see all the mono behavior stuff. All right, so let's get back to the C home controller. You see that as we come in, we have this constant defined here called mCustomized info, and I have like a 1010. That's essentially being used as a tag, and the reason why I say this is I have to know the very first time the game is run, because it's installed on your system, and at this point there is no player preferences file because it hasn't been created. Okay, so what will happen is that the system will come in, and the start event is the first event that happens when a scene is loaded, and you'll see that in this case it comes in, and it checks to see if this customized value on the player preferences is equal to that 1010. Like I said, player preferences, if the file exists, it's loaded. If it's not exist, it isn't loaded. And in this case, player preferences would have a 0 in it because, or a blank. In this case, it's an integer, so it'll be a 0. And so now that tells me that this is the very first time this program has been run. So I need to initialize all the information to known values, and then I save that to the preferences file, and now it's there for next time. So the next time it comes in, it looks and sees that customized is set to 1010. I know that the parameters have been set up, the file is set up, and this information has information in it that was set up from before, skill level, who goes first, the mode, and so forth. So I don't have to initialize it. So that's where it gets ignored. And I just use what I get loaded. That's what you see there on the start. Okay, process request is the event that's executed when a button is pressed. And as you can see, there's a case statement, switch statement, and the switch statement has all the options for the different menu buttons: start, level, mode, player, and exit. And each one loads a new level. All right. You'll also see that an audio.play command is used, and that'll be consistent. That's essentially the sound of the button being pressed. You hear the click. Okay. And that's all this does. It's a menu. All right. So let's look at the menu buttons. And you'll see that the menu buttons has in it it initializes the button type, because that determines whether it's there's a start button or which button and so forth. You have to initialize it to something, so I initialize it to start. And so now we'll come in the start event of the the C menu buttons. You'll notice that they derive from C button touch logic. Okay, if I go and look at C button touch logic, you'll see that's deriving from common constants, and common constants derives from mono behavior. All right, so the job of C button touch logic is that when you have a mouse and you're clicking buttons, a mouse you can only click in one place. So you can't have multiple mouse clicks at the same time, but you can have multiple touches at the same time. So you have to have a way to represent those multiple touches. And Unity 3D does this by holding a collection of touch to create touch events. And what this is doing is this is walking through a collection of the touch events that occurred while the game player was pressing the screen. And then it appropriately sends the message on touch move, on touch stationary, on touch end, cancel, and begin, and so forth. All right? So on touch begin is when the person presses down. On touch end is when the person picks his finger off the button or the screen. And those are pretty much the ones that we're using now. I could use all the other ones, but I don't have the need for a swipe yet. Touch, pinch, expand, rotate, and so forth. That's what these messages correspond to. Okay, so let's get back to menu buttons. So now you'll notice that in the start portion of this, menu buttons script has to attach to the home controller script. And the way it does this is through this, it does this at the start event. Now, you notice there's a while loop. And I'm constantly testing to see if the home controller object is still null. You have to do this because there's a lot of asynchronous stuff going on when a scene gets loaded. And until everything is loaded completely, the home controller object won't be created. So you don't want to all of a sudden find out that you're at the point where you just missed, you're at 0.9 of 10 points and the object hasn't been created yet, and then you continue and now you have a null object and your your code starts failing because you're accessing the null object. So this loop will continue and stay in this loop until all the assets, everything that's supposed to be loaded is loaded, and the object is created, and then it sets the done variable that drops me out of the while loop, and now I can continue. So I know it's an attachment. You'll see this a lot in all the button scenes and so forth. It's an important thing to remember. If you don't do this, you'll have it's very problematic. All right. So now there's the on mouse down, on mouse up, on touch begin, on touch end, and then there's the process request. You notice I'm not using on touch ended, and I'm not using on mouse up. I only care that the button has been pressed down, and I only care that the person put his finger on the button and pushed instead of coming up. Now, I could have used those events for other features, other things. I just haven't chosen to do that. Now, if you look at this script, it's pretty generic. I mean, it calls this thing called process request, which is the same method that's in all of the controllers, and it essentially has the same job. It takes the user input and passes it on to the main controller so that it can do something with it. But I decided to leave them as separate classes for each of the scenes because, if I had a common one, then if I want to do something special for a particular scene, I have to be careful not to break, the stuff that's happening in another scene. So if I have them separate, now I can later on, if I want to do something on the mouse up that's different from the mouse down, I can do that and not affect anything else but the scene. So it encapsulates it. It has good cohesion, and it minimizes the coupling effect of trying to make sharing things. And it's very small code that's used, and it makes it more readable and clear to the person that's using it, to the developer. Okay, and now you'll notice it comes in and it checks to make sure the home controller is null. At this point, I really don't have to do this because this check has already been done before I even come down here. But this is just a precaution in the event that I do something else and it causes this variable to change or something happens. And you'll see that what it does is it calls the process request, passes the button type that was pressed. In this case, was it a start button? Was it a level button? Was it a skill button? Was it a mode button? Or was it an exit button? And that information gets passed to the process control. Okay? So that's what the menu button does. And so we'll look at the home controller again first. Then you'll see that the process request takes the button type that was passed in, and in the switch statement, it knows what to do with it. Like I said, start, level mode, which scene to load, or to quit. All right. So now we'll go to the CBoard controller. That's the main program for the game scene. That's where you see the tic-tac-toe table. That's where you see all the asteroids and the ships, and that's where the main activity occurs. That's the game area. That's where we do things. So you'll see that it's also serializable. And okay, and you'll see that this C strategy info is a class that I use to keep track of my min-max information, and for the min-max algorithm. And so then here's the CBoard class. It derives from common constants, which derives from mono behavior. Here are the objects that you see where I'm entering the asteroids. You'll see that I created as a public. Now it'll show up in the property, and that's where you map the asteroid's virtual variable to the actual assets. So this is the fashion it's done. Anything that's public, it'll be up in the properties area of the Unity editor. Anything that's not, anything that's private, you won't see it up there. It'll just be private to the class. I've defined some constants that are used in the game. All right. I've defined the strategy information, as you see here. And then we go to the Start menu. And in this case, I'm not instantiate. I don't have to sit there and try to instantiate any object like I did in the buttons. So there is no need for a loop until I get the object. I am the object. So we'll go to this method here called initialize gameplay. And what initialize gameplay is doing is it's initializing the arrays. It's setting the list of locations all to unassigned. It's instantiating the asteroids. It's initializing all the min-max variables. And it's setting up the information that's needed for the very first time for the player preferences. As you can see, it's drawing information from the player preferences and deciding who goes first, and is it the AI, and how hard the game is. All right. So once we do that, we'll come back to the start. We'll look at here, and it comes in, and here's where it comes in, and it says, okay, do I have? There's this update display info. Now, this has to be set up as a coroutine. If you don't set it up as a coroutine, what happens is that you have issues with, it's like threading. So it'll end up blocking if I don't do that. Now I have to keep the name of the player that's up at the screen at any one time. So you'll see there's things like Goombot's turn, player 1's turn, player 2 turn, and so forth. And you need to keep that up for a certain amount of time until everything has synchronized and it's time for the next player to do that. So what I'm doing is that I'm sitting in a loop, and on that loop I'm checking for an animation done command flag to be set. And that's when the object goes off the screen, hits the boundary, it tries to exit the boundary, gets destroyed, and a flag is set to tell me that that scenario is over, and now it's time to start the next one. Then I fall through the loop and display the new message. That's what's happening there, and we'll go and if we go and look at that routine right now, that's exactly what you'll see. So we'll go to the declaration, and as you can see, we're sitting in a loop. Is animation done? And if the animation is done, then I fall through and I go and update everything accordingly. Okay? So I first have to check to see if there are any moves left, and then that determines what type of message I throw up. As you can see, the message is there. All right, that's the update display loop command. Okay. All right, so we'll go back to where we are to start, and we'll come down now, and we're trying to decide who goes first, and that type of information in the current state. Okay, so we'll talk about the rest of this in the next part of the video. See you soon.